Welcome to this video, guys. I am going to be taking you through the GCSE Maths Paper number 1, 2024 from the Edexcel exam board. Now, I have done these solutions. They are my own solutions, and I am releasing this video 1 year after the exam has been sat, so this respects exam board guidelines. One thing to note is I am not just going to be teaching you how to answer these questions on this particular paper, but how to develop the sort of thinking that is required should these topics come up again. So fasten your seatbelts and let's get started. Okay, so here we have question number 1. An arithmetic sequence is given to us and we've been asked to find, in terms of n, the nth term of this sequence. The very first thing that you want to do is find the common difference. As you can see, the gap between 1 to 5 is 4, 5 to 9 is also 4, and 9 to 13 is also 4. And what do? We write down 4, that difference, with an n. Then we go back to the first number, the first term, and we go backwards. So if going forwards was to add 4, going backwards would be to minus 4. So we are going to minus 4. So what happens when we do 1 minus 4? We get minus 3. And this is just added to our sequence. Now, what you could do in an exam is just check that this is correct. To see if you've done anything wrong, this will highlight it. So for example, if we take the third term right here, the third term here is 9, okay? So n will add, well, we'll make n 3. So it will be 4 times by 3 minus 3. Now, if this is correct, if this rule is correct, where we have taken the n value to be 3, it should give us the final answer of 9. So let's see. What's 4 times 3? That is 12 minus 3. It gives us 9, which means our sequence rule is correct. Let's move on to the next one. Question number 2. It says work out. Remember, it's a non-calculator paper. So you've got to do everything without a calculator. So what do we have? We have two mixed numbers and we are taking them away. Very first thing you want to do is make the mixed number into top heavy, both of them. So how do we do that? We multiply the big number with the denominator, so 3 times 5, and then we add the number on the top, which is 4. So 3 times 5 is 15, add the 4, we get 19. So it becomes 19 over 5. Then minus, this is just that drop in. We do the same thing here, 1 times 3, that is 3, add the 2, that is 5. So it becomes 5 over 3. The second step, because when we take away and we add, we have to have the denominators the same. At the moment, we've got 5 and 3, not the same. So how do we make the denominators the same? We normally look for the lowest common multiple. So what does 5 and 3, what do both those numbers become? They can become 15. So we can have 15 as a new denominator for both of our fraction. So then we have to ask ourselves, how does 5 become 15? Well, 5 becomes 15 if you multiply it by 3. And then we ask ourselves, well, how does 3 become 15? Well, 3 becomes 15 when we multiply by 5. So if we are taking this first one and we're multiplying it by 3, we've also got to multiply the 19 by 3 as well, which means 19 times 3. And again, it's a non-calculator, so you have to find techniques of doing this, okay? Now, 19 times 3 might be difficult for some students to do in their heads. But what you can imagine is 20 times by 3. That's a lot easier to do. 20 times by 3 is 60. But what are we adding extra? We're adding that, from 19 to get to 20, we added 1 extra. So that's 1 times by 3 we've added extra. So we can take that away from 60. 1 times by 3 is 3. So that gives 60 minus the 3, which is 57. See? In your head. Same thing with this one, but this one's a lot easier. 5 times 5 is 25. I'm sure you can do that. So now we have 57, take away 25. We just need to do that top. Now, if you can do this in your head, great. If you can't, there's no shame in doing 57, take away 25, making sure that you don't make any mistakes. So let's quickly practice that. What's 7, take away 5? That is 2. And then what's 5, take away 2? That is 3. So the answer becomes 32. Now it's 32 over 15. That's your final answer. A common mistake some students make, I don't know if they will make it here, because I'm sure it's quite self-evident, is they tend to take those away. So if you're a foundation student who just stumbled upon this video and you're watching this, I don't know why, then yeah, please you don't take the bottom away once you've got the denominators the same. It's just the top. Okay, so the answer is 32 over 15. However, usually a good rule of thumb is if you're given mixed numbers, give your answer as mixed number. So then you have to ask yourself, how do I convert this into a mixed number? You do. How many times does 15 go into 32? Well, 15, 30. It definitely goes in 2 times. That's 2 big ones. And what's the leftover? 2. So 2 out of 15. And that's your final answer. If you can simplify that fraction, you should try to do that. But in this example, you can't. So this is your full and final answer. Moving on to the next part of this. Okay, what do we have here? It says Kevin was asked to work out 2 1/3 times 5 over 8. And this is what he's done. His answer is wrong. What mistake has Kevin made? Most probably, it's probably the same mistake that some of you make. You know, when you see this and you're like, no, I've got to get the denominators the same. That's what you start doing when you see multiplying and division. Well, for multiplying and division, you do not need to make the denominator the same. All right, you don't need to do that. So what you could do is go through this working out. But what I recommend to my students is ignore their working out and you do it yourself. You do this question. So you do 2 1/3 times 5 over 8. What would you do? And then you can see what Kevin's done, and then you can know exactly what the mistake is. So first things first, let's make the denominators the same. Not the denominators the same. This into a top heavy. Okay, so 2 times 3, just like we did earlier. So 2 times by 3 is 6. Add the 1 is 7. So we get 7 over 3 times by 5 over 8. Let me make that 3 a bit nicer there. All right, so what do we do here when it comes to multiplying? We just multiply straight across. No making the denominators the same at all, like I said earlier. However, sometimes you would look diagonally and see if you can cancel down diagonally. But in this particular example, you can't. So let's just do 7 times 5 and 3 times by 8. 7 times 5 gives us 35. 3 times by 8 is 24. Let's now make this into a mixed number. So how many times does 24 go into 35? It goes in once. The leftover from 24 to 35 is 11. So 11 over 24. That should be the answer. Now you can clearly see that Kevin didn't get this answer. And let's see what Kevin's actually done. He's done the 7 times 5 and 3 times 8, because he did make this into mixed numbers like we did as well, by the way. So he's done that correctly, but it seems that when he tried to make it into a mixed number, he didn't get that correct. He done 24 into 35, and then the gap between 24 and 35, he wrote down as a 9, but it's 11. So that was his mistake. You can highlight it right there. And just what would you say for 1 mark? I mean, you've done practically this. This is not really adding to the mark unless you write down the mistake that he's made. So you could say that he converted incorrectly top heavy fraction, the top heavy number, to mixed. Okay, and you've given the solution. You should say something like should be 111 over 24, something like that. Okay, right, next question. Question number 3. How many marks? 4 marks. Okay, actually 5 marks in total. So there's part B to this. Okay, so Petra is going to cover this floor with paint. She has 3 tins of paint, and there are 2.5 liters of paint in each tin. Petra thinks 1 liter of paint will cover 10 meters squared of flooring. Assuming Petra is correct, does she have enough paint to cover the floor? First things first, we need to cover this. So we need to find the area of that. Now, you can't find the area of this directly. You might want to split it up. Some students may decide to make this into a full rectangle and then find the area of that and take that away. Okay, whatever you do. I am going to just split up this diagram. Either you could split it up this way or you could split it up this way. It's completely up to you. I'm just going to go this way. I'm going to split that up. All right, so I have 2 different shapes. I've got shape A here and shape B here. So if I look at shape A and then shape B, I can do them individually. For shape A, I have 10 meters on the top here, and this is 5. Okay, so that's 5 meters there. That's 10 times by 5. That is 50 meter squared. And for shape B, I have 6 meters along here. And this I don't have right now. But if I know that all of this is 8, and I know that this is 5, then the gap from there to there would be 3 meters. All right, so once again, from here to here is the same as that, 5. But all of that is 8. So therefore, this must be 3. Okay, so you got your 5 here and your 3 there. All right, so that's 3 meters. So that would be 3 times by 6, which is 18 meters squared. The total is to add all of this up. So I can say the total area is 50 plus 18, which is 68 meter squared. Right, now, the area of this is 68 meters squared. Petra's, let's see what she says. She's got 3 tins of paint. Each is 2.5 liters. So therefore, what we can do for this paint part, we can say 3 times by 2.5. So this will work out the total amount of liters that she has. And 3 times by 2.5 is 2.5. 2.5 is 5. And another 2.5 is 7.5 meter squared. All right. She thinks that 1 liter of paint would cover this much. So this is, sorry, not meter squared. I shouldn't do that. I've done the units wrong. It should be 7.5 liters. There we go. Right. So how much of that is needed? All right. So she thinks that 1 liter would cover that. So basically 7.5 liters would be 7.5 times by 10 meters squared. Because remember, 1 liter, she thinks would cover 10 meters squared. So that's how much we can cover, which is 75 meters squared. So she can cover a floor of 75 meters squared. Our floor was 68 meters squared. So we're going to assume that she's correct, as the question says. Does she have enough paint? Yes, she does. Okay. Yes, she has enough according to her assumption. Okay. Next part. Actually, 1 liter of paint will only cover 11 meters. Square meters of flooring. Does this affect your answer? Well, we had 7.5 liters. We were told that you can cover 10, but actually it can cover even more. Well, actually, we don't need to write that there. Of course. Yeah, I mean, it doesn't affect our answer at all. So doesn't affect because we have even more. It means we have even more. It means we have even more paint. Okay, there you go. All right, question number 4, Venn diagrams. All right, write down the numbers that are, what does this mean? A lot of students get confused with these. So I'm going to break it down for you here. If you have P, that means within the circle of P. The moment you add a dash, it means not P. So not inside this circle. So we're looking for numbers that are not inside the circle. As the question says, write down the numbers that are in set not P. Okay, so what is not in P? Well, if this is your P, if this is all your P circle, we color it out. What's not in there is that, and that, and that. So these are the numbers that you need to write down as your list. So it doesn't have to be in order. So just do it as you see it. So 10, 14, 11, 13, 16, and 17. There you go. Next, a number is chosen at random from this universal set, and it's just a funky number. That means all of the data set. Find the probability. I'm going to highlight this. Okay, that this number is in, what does that mean? Okay, so once again, P that Q. It means or. This thing here, it means or. So it's in P or Q. Sometimes the student might see something like this. This means and. What's in P and? Okay, Q. So this way, we want P or Q. So what are the numbers that are in P or Q? So this is the P circle, and this is the Q circle. What numbers are in either P or Q? We have 12, 15, 18, 10, and 14. Now, this is a probability. How many numbers are in P and Q? 1, 2, 3, 4, 5 out of the total number of numbers, which is 5, there's 6, 7, 8, 9. So 5 out of 9. 5 numbers are in P or Q out of the total, which is 9 numbers. Question number 5. Okay, Sophie drives a distance of 513 kilometers on a motorway in France. She pays this much for every 10 kilometers that she drives. Work out an estimate. Now, a lot of students miss this word. If it's an estimated question, it means you round, possibly to significant figures, one significant figures, or whatever. Okay, so remember that. Now, the total amount that she pays is going to be 0.81 euros for every 10 kilometers. But how many kilometers does she drive? She drives 513 kilometers. So the first thing we want to do is 513 kilometers, we want to round it to something. But just before we get to the rounding, let's just do the actual calculation first, okay? So we know that she drives a distance of 513 kilometers. She has to pay 0.81 euros for every 10 kilometers. So the first thing we want to do is work out how many 10 kilometers are in 513. So we divide that by 10. Now, of course, without a calculator, it might be hard for some people to do. So we're going to approximate, estimate. Okay, so 513 can be rounded to 500 and 10 can stay as it is. And that, we can just cancel out these 2 zeros there, and that gives us 50. So we have 50 lots of 10. For every 50, for every 10, so 50 lots of this, let me do that again. We have 50 lots, okay? And for every lot, we have to pay 0.81 euros. Okay, so we're going to do 50 times by 0.81 euros. Once again, it's going to be quite challenging to do this calculation. So this can be estimated. Some students round this, a number like this, 0.81, to 1. Common misconception, common problem, okay? Because you're rounding too much. Instead, you should round to one significant figure, and that would make it 0.8. Then you ask yourself, how do I do this calculation without a calculator? Well, you just do 5 times by the 8. What's the answer to 5 times by 8? It is 40. And then you say, right, there's 1 0 here. I'm going to add that 0 right there. But then this part of it says, well, there's 1 decimal place. So I'm going to have to give this 1 decimal place. Where would the 1 decimal place be? If I want this answer to have only 1 decimal place, it has to be between the 2 zeros. So it ends up becoming 40 in the end. So my answer is 40. By the way, this is 40 euros. And there you have it. Now, in your answer to part A, I've read that wrong. Is your answer to part A an underestimate, or an overestimate? And give a reason for your answer. Well, let's see what you've done. You have underestimated. You've gone under from 513. You have gone down. Okay, so there you've gone down. So possibly you could be having a little bit more there. Here again, you went down. So again, you could be paying more there. So it's an underestimation. So you could say something, it says give a reason for your answer. You could say 513 has been rounded down to 500 kilometers, and 0.81 has been rounded down to 0.8. So it's an underestimate. There you go. All right, next question. Here is a straight line drawn on a grid. Find an equation for L. Right, equation of a line. So straight away, the moment you read that, you should be thinking y equals mx plus c. Now, I have to always remind some students, because some of you guys might be in the top sets, in the higher sets, you know what you're doing. But my videos are going to be for the poor student who hasn't been working hard, and we can't abandon them. So we've got to give them that little bit of extra. So first of all, guys, M, what does this mean? It means the gradient of your line, which means how steep your line is. And to find the gradient, I mean, look, you're not going to, if you don't know anything here at all, you're not going to learn this without going back to one of my videos, perhaps, on how to find the gradient of a straight line. and things like that, right? So you won't just learn it here. This is just a little bit of help, right? Or a reminder for some students, okay? So how to find the gradient is to draw a right angle triangle underneath, not that one. I'll show you when I do it. And yeah, you just find the difference in the y divided by the difference in the x. Then the C. The C is where it cuts the y-axis. So the y-intercept, all right? So this is the y-axis. Where does this line go for the y-axis? Right there. Okay, so we've got that straight away just by sight. Okay, so let's focus on the gradient first. So the gradient is the change in y, or the difference in y, divided by the difference in x. I just write y over x. Some people write change in y over change in x. Whatever, it doesn't matter. But the most important thing is where to draw your triangle. So the triangle has to be something that goes underneath, like in the corners of these boxes, not like here, for example. Can you see that's not a good place to draw your triangle at, or an end there? All right. So it can be as big or small as you make it, as long as it does those things. It goes through, like starts on a corner. So this would be a nice one. I think that's all right. Okay, and then you find the gap. All right. Some questions, by the way, please read the units that you're given, the intervals. Yeah. So sometimes 2 squares can be 1. So be aware of that. Anyway, here you got this as 6. And the gap here is from -2 to 2. So that's 4. So 6 is your y right there. And 4 is your x right there. So you have 6 divided by 4. Again, no calculator, remember? So you've got to do this without a calculator. If you can't do that straight away, you can simplify the fraction down. So 6 can be, and 4 can both be divided by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. The answer is 3 over 2. You can leave it as 3 over 2, or you can say 1.5. Okay, but now you know your gradient. 3 over 2, or 1.5 in for that m, and c is where it cuts the y-axis. As you can see, it cuts it as at +3. So the equation of the line would be something like y is equal to 1.5x plus 3, or you could write, instead of 1.5, you could write 3 over 2x plus 3. Either of those is fine. Yeah, either is fine. Right, now we're told that m is a different straight line with an equation of y equals 5x. We have to write down an equation of a straight line that is parallel to this. What do we know about parallel lines? When 2 lines are parallel, their gradients are the same. Okay, so if this is y equals 5x, and we are saying that this line here is said to be parallel to that, then the gradient will be exactly the same. So it could be something like y equals 5x plus 10, y equals 5x minus 2. It doesn't matter. Any equation you just give here. So you could say y equals 5x minus 3. Okay, as long as it's not just y equals 5x. Obviously, otherwise that would be the same line and not a different line. Okay, so it could be something like that, anything. All right. Next, number 7 here. It says Qasim has some small chairs. Jars. Man, sometimes you know what? You got to be careful about this as well. If your mind is like me, I sometimes read something and my brain just inserts another word. I mean, here's a minor thing, but sometimes it can happen with numbers. Yeah, so just be careful with your reading. Just take time. In fact, read twice questions. You'll see later on when we do questions like a big one, we have to keep going back and reading it again and again. Anyway, where are we? Qasim has some small jars, medium jars, large jars, and he has a total of 400 jars. 3/8 of the jars are empty. Let's focus on that straight away, actually. Okay, so we know we need to work out 3/8 of the jars, which is of 400, and we know that it's empty. Now, in mathematics, of means times. So literally, we're doing 3/8 times by 400. So how do we do with that? This is our empty jars, by the way. How do we do with that? We do 400 divided by 8. Again, we can cover up a 0, or even 2 zeros if you want to, and do 4 over 8, but I would do 1 0 actually, yeah? So 40 divided by 8 is 5. And then add that 0 back, so it's 50. So that was 400 divided by 8. But then the number here, we have to times it by that. So we have to do 50, the answer that we got, times by 3. So we get 150. So we have 150 empty jars. Okay. How many jars left? Okay, how many jars are left? So if we do 400 minus 150, what's left is 250. So we've got 250 jars left. I don't know if that's going to be important in the grand scheme of things, but just write down stuff like this anyway, if you want to. For the empty jars, so for these 150 jars, that is, the number of small jars, so we don't need that probably right now. The number of small jars to the number of medium jars is in this ratio 3:4. So for the empty jars, we need to split it up in the way of small and medium in the ratio of 3:4. So how many empty jars were there? 150. We need to break it up into that ratio, but not yet because there's a bit more to this, medium to large. So we need to do another one. So this time, I'm just going to add the large right there, okay? This time on another line, because it's still comparing medium and large, on another line, we are going to do the medium to large comparison, and that is 1 to 2. So 1 to 2. So just in case I've lost anyone, the first line here, it says small jars to medium jars is in the ratio of 3:4. There we go. That's that comparison. Second line is comparing medium jars to large jars, which is in the ratio 1 to 2. So medium to large in the ratio 1 to 2. Medium is the common thing here. That's why I've got them underneath each other. And you'll see what I do with that later. Okay. Now, work out the percentage of Qasim's jars. That's our question. Work out the percentage of Qasim's jars that are empty and small jars. Okay. So first of all, what we need to do with this question is compare it across small, medium, and large. And then we can divide those 150 jars accordingly. All right. But first, we need to handle this. We need to merge them together so that we can compare small, medium, and large. So the common thing was that 4 and 1 for the medium. What can those numbers become? Both of them, the lowest common multiple. Well, we can make that 1 into a 4. All right. So if we write 4 to represent, both of them, okay, because that way we can turn this by multiplying by 4 to become 4, and then that would be represented of when it's compared the medium with the small jar. Okay, now the question we've got to ask ourselves is, how do we do that? We times by 4 here, but we've also got to do that to keep that ratio between the medium and large consistent. So 2 times 4 is 8. And then because this has been untouched, the small and medium comparison, because medium represents 4 here, this can just come down here and join them as it is. So now we have small, medium, and large comparison of the ratios in the ratio of 3:4 to 8. Now, we are just interested in now breaking down the 150 empty jars into this ratio, 3, 4, and 8. So we need to add 3, 4, and 8 first. So 4 plus 8 is 12, plus the 3 is 15 parts. And then we need to do 150 divided by 15. Again, without a calculator. So if you cover up the 0, 15 divided by 15 is 1. Add the 0 back. So it's 10 jars in each part. We are just interested, we can do times by 3, times by 4, times by 8 and have all of them, but we're just interested in the small jars, which is right here, which is the 3 parts. So just for the small jars, I don't know why I wrote jar. So jarring. So I would say some of my students sometimes when you ask them to do stuff, or I hear other teachers, they don't do it for me. They always do stuff for me. So 3 times by 10, that's 30. So 30 small jars. All right, now it's asked for a percentage, didn't it? So it's a percentage of the overall amount of jars, isn't it? Overall, yeah. So 400. Okay, we still didn't need that. So 400 jars was the overall. So it would be 30 over 400 and times by 100 to make it into a percentage. All right, how do we deal with this? We can cover up these zeros right there. So we've got 3 over 40. So we have 3 over 40 times by 100. Then what we can do is cancel out another 0 right there. Okay, so we can do that. So what do we have now? We have 3 times by 10 over 4. Let's do that. 3 times by 10 over 4. That is 30 over 4. That's, again, you can just do 30 divided by 4 if you want to, or you can break it down, like cancel down. So 15 divided by 2, and then you got 7.5. That's easier to handle. So 7.5 is my final answer. Question number 8 for 3 marks. Len has a parcel. Len has 8 parcels. Let's do that again, shall we? Question number 8. Len has 8 parcels. The mean weight of the 8 parcels is 2.5. The mean weight of 3 of the parcels is 2 kilograms. Work out the mean of the other 5 parcels. Right, so this is one where the questions, we need to really learn how to break this down, right? So let's highlight this. So it says the mean weight of 8 parcels is that, 2.5. What is the mean? How do you calculate the mean? It's the total, like add up all the weights, divided by the total number of things there are. We know that there's 8 of those. So this would be x, we don't know. We don't know, x would be like representing the total of all 8 parcels weights when you add them up. We don't know what that is, so we're just going to call it x. Divide by 8. That equals to the mean, which is 2.5. Okay. For this one, it says the mean weight of 3 of the parcels. So we know it's going to be divided by 3 is equal to 2 kilograms. But again, we need another, like, what is the total weight of these 3 parcels? We don't know what that is, so we can give it another letter, which is y. Don't be confused by what x and y means. I mean, I could have used, like, instead of x, I could have wrote total weight, but it's so long, of 8 parcels. And for this one, I could have written total weight of 3 parcels. Yeah, but x and y is just easier to represent. Okay, so just remember what that means. Okay, x means the total weight of 8 parcels, and y is the total weight of 3 parcels. All right, so now what we can do, see here, we want to make x a subject, we can multiply by 8. So if we can do x is equal to 8 times by 2.5. We need to work that out, and we're going to do the same thing for the second one. We're going to do y is equal to 3 times by 2. That's easier to do first, so let's do that. That's 6. So that is the total weight, remember what it was, of the 3 parcels, and x is going to be the total weight of all 8 parcels. But we need to do 8 times 2.5. So how do we do 8 times 2.5 without a calculator? Well, you could do 8 times by 2, and you could do 8 times by 0.5, and then add that up. So 8 times by 2 is 16. 8 times by 0.5, which is the same as a half, so half of 8 is 4. And the total of that is to add those up, which is 20. Okay, so 20 is your x is equal to 20, and this is the weight of all 8 parcels. Okay, so now it wants us to work out the mean weight of the other 5 parcels. So we've got the total weight of 3 parcels, which is 6 here, and the total weight of all 8 parcels, which is 20. If we take them away, we'll have the weight of other 5 parcels. That's right, other 5 parcels. So that will be 20, take away 6, which is 14 kilograms. By the way, they're all in kilograms. So 14 kilograms is the weight of the other 5 parcels. So to work out the mean weight of the other 5 parcels, it's going to be mean of the other 5 parcels, which is 14 divided by 5. We need to do 14 divided by 5 without a calculator. So how do we do that? Let's zoom in here. Now, I can either do how many times is 5 go into 14, that method, or I can make the 5 into a 10, and it's easier to see, work out fraction to decimal from that. Okay, so whichever way you want to do. I'm going to go with multiplying it. Okay, I'm going to multiply by 2 to get my 10, isn't it? So it's going to be 10, and 14 is going to be 28. And now that is basically 2.8 kilograms. So the mean weight of the other 5 parcels is 2.8 kilograms. If you did want to do 40, how many times is 14 going to 5? Let's do that way as well for you. So how many times is 5, go into 14? 5, 10 twice. Left over 10, 4 over 5. So 4 over 5 is 0.8, so it's going to be 2.8 kilograms. So you can also do it like that as well. Okay. Now I'm going to get rid of that because that's going into my other question. So yeah, I'll leave that my bit. All right, question number 9 now. In a sale, the normal price of a coat is reduced by R%, given that the sale price is equal to 0.7, which is a multiplier. No. Yeah, it is a multiplier, times by the normal price. Find the value of R. So look, I just want to introduce you in case you haven't seen this one. Original amount times by the multiplier. Very powerful percentages formula I used. You can use it for a lot of things, this one, okay? So we are told this is a sale. The normal price, which is going to refer to your original amount here, okay, that's normal price, is reduced by R%, okay? So you can see that reduction. That's a multiplier, by the way. The reduction is a multiplier, okay? So the normal price is right there. Can you see? All right, so your multiplier is 0.7. So your original amount you don't know. We're going to call that X. Times by your multiplier, which is 0.7. Now, we also don't know the new amount. Now, this is not that sort of question, though, okay? This is not the question where you do that. You have to work out what R% is. What is your discount? Well, this is your clue right there. Your clue is right there, okay? This is where the discount comes from. So normally, all percentages are of 100. This has been reduced to something, 0.7. 1 take away 0.7 is 0.3. So it's been reduced by 30%. Okay, so let me give you another one. All right, imagine I said to you that something has been reduced by 60%. You do 100, let's do 100% essentially. Take away the 60%, that is 40%. So a multiplier for a reduction of 60% would be 0.4. Okay, so if you see 0.4 in here, where something's been reduced by, multiplied by 0.4, the normal price has been reduced, then you should know that it's been reduced by 60%. Okay, so let me ask you another one, and you can write it in the comments for question number 9. Yeah, you can say question number 9, this is the answer. If I reduce something by 15%, so if it's a 15% reduction, what multiplier would I use? What would be my multiplier? Let me know in the comments. All right, let's move on. Question number 10. Did we finish this? So it's 30%. We just need to write that there. Okay, now let's move on. Right, we got question number 10, simultaneous equations, and we've got, okay, first things first, label it 1 and 2. The amount of times I see students who don't label it and they like, do it in this one. I'm like, what's this one? You can just say equation number 1 or equation number 2. It's much easier. All right, what we're looking to do here, we are looking to make one of the letters, either the X's or the Y's, the same. You could make any, it's your choice. I think I'm going to go with the X's because they're both positives. I don't want to deal with the negatives, but of course I can. But anyway, if you are going to deal with the Y's and make them the same, then you'll take this one and multiply it by 2. And you'll take this one and multiply it by 3. So you could go ahead and do that, but the answer will be the same at the end, all right? Just remember that. But I'm going to go with this. I'm going to multiply this, and I'm going to multiply this. I think I'm going to get 10, aren't I? So I'm going to multiply the first one by 2 and the second one by 5. So if I multiply the entire equation now, remember, that times by 2, that times by 2, and that times by 2. So 5x times by 2 is 10x. Minus 2y times by 2 is minus 4y, and 23 times by 2 is 46. Same with this one now, but times by 5. So that 2x times by 5 is 10x. Minus 3y times by 5 is minus 15y. And 18 times by 5. See, now we have to work that out. Okay, so look, I'm going to do it here. 18 times by 5. Okay, quite hard to do. So what we can do is we can look at 18 times by 10 and then half the answer. So 18 times by 10 is 180. Everyone knows that. But then we've got to half the answer. So we've got to do 880 divided by 2. And that is 90. There we go. So we've got 90. All right. So if you can't do stuff like 18 times by 5, don't fret. You can use methods like this or just use long multiplication if you have to. Whatever you need to use. Right. Now you need to get rid of these. Right. You need to get rid of the 10x's. Now notice here, this is the bigger value equation. You can do it right. How do you get rid of them? You're going to take them away because that's the way you get rid of positive 10x and a positive 10x. Yeah. But what you could do is take this one and then write this one underneath it. All right. So you could write down 10x minus 4y equals 46 and take them away like that. So that way you avoid negatives as much as possible. Okay. So you're going to take this away now. All right. That's 0. You don't need to write anything there. Now this one is important. Minus 15y minus 4y. So these two negatives will become a positive. All right. So you do minus 15y plus 4y. What's minus 15y plus 4y? That is minus 11y. Okay. So remember, minus 15y minus is a positive here. So that's why this becomes a plus. So you do minus 15y plus 4y. 90 minus 46. Again, something that you might want to go to the side and do like that. No shame in it at all, okay? Or a quicker way is I say how many times, if I get this to 50, it'd be easier. So I know the gap between 50 and 90 is 40. What do I need to add to get to 50? 4, okay? So it becomes 44, all right? So 44 is your answer there. Now, you need to do 11, divide minus 11 on the other side. So you have y is equal to 44 divided by minus 11. And that gives us minus 4. Okay, 11 times table is quite easy for everyone to do. Right, where are we? Okay. Right, now we do the substitution. So sub y equals minus 4, and you sub it into any of these two equations. Now I'm going to pick number 1, but you can pick number 2 as well. All right, just make sure that you do any checks or anything into the other one. All right, so I'm going to pick equation number 1. Equation number 1 is 5x minus 2y equals 23. My y is minus 4, so I'm going to do 5x minus 2 bracket. I'm going to put my minus 4 in there, and that should give me 23. So if I do that calculation now, 5x minus 2 times minus 4 is plus 8 is equal to 23. And then I'll take this 8 to the other side. So now I have 5x is equal to 23 minus 8, which is 15. X is equal to 15 divided by 5. X is equal to 3. So that's my solutions now. Done. But let me do that check quickly, because this is something I teach my students. So x is equal to 3, y is equal to minus 4, and I'm going to check this in equation number 2, which I haven't used. Because I use equation number 1 already to do the substitution, I have to use the second equation to do my check to keep it cushy. All right, so equation number 2 is 2x minus 3y equals 18. My x values are x is 3 and y is equal to minus 4. So 2 times 3 minus 3 times minus 4 is equal to 18. And what is 2 times 3? So 2 times 3 is 6. Minus 3 times minus 4 is plus 12. Does 6 plus 12 equal 18? Yes, it does. It means my solutions for x equals 3 and y equals minus 4 are correct. So 3 and minus 4. Okay, there's your confirmation in the exam. Make sure you do this test, this check. Right, 11. All right, now it's a rotation. Describe this. Right, now I won't be able to show you this because you obviously need to see an overview of my screen with my hands moving on top, but you can't see that on this setup. So I'm going to have to tell you or describe to you as best what to do. Okay, so you need to work. Okay, first of all, let's read the question. We haven't even done that. I'm already talking about the limitations that we have. Right, triangle A is translated by this vector. What does this mean? It means that it moves 6 to the positive side. This is why that is a positive. If it was minus 6, it would move 6 that way along the x-axis like that. So the number on the top tells us the x, which way it moves left and right horizontally. The number on the bottom here tells us our y, up and down, the y-axis stuff. Okay, so this one, it moves 6 to the right and 4 down because, oh my god, my handwriting is terrible. Hope you can listen to that again. Right, so it moves 6 to the right and 4 down. Okay, so this thing here is going to move 6 this way and 4 down like that. Okay, but we're going to do it properly. We're going to follow by a corner. We're going to take a corner and move it 6 to the right. 1, 2, 3, 4, 5, 6 right there, and then 4 down. So 1, 2, 3, 4 right there. So see that corner right there? It ends up being there. And then what we can do is draw the rest of the shape out like that. Okay, right there. So that's where my first transformation takes it. Okay, and this is triangle B. It says it gives triangle B. Then this is rotated 90 degrees clockwise about the point 1, 2. So from the point 1, 2, it gives this triangle C, and you have to describe, well, let's see where it ends up. And this is the part that you can't see me doing. All right, so I'm going to, basically what you'll do is you get your tracing paper. I'm going to still show you how to do it. Get your tracing paper in the exam and see this point right there, mark it. So 1 to 2 right there. So with your pencil, just mark it there with a north arrow this way, and then make it rotate 90 degrees clockwise. 90 degrees clockwise would be this way. Okay, so until you know that north arrow, that's why we do it. You're looking for it to turn like that on your paper, and then this will also switch and go that way. All right, and then you'll be able to see where this triangle ends up, and you just trace it wherever it is. It's somewhere there, I could tell. All right, so I'm going to show you where I've done it. So it ends up being here, here, and here. There. So that's your triangle C. Now what the question wants you to do is describe how A directly goes there with one single transformation. So as you can see, you did two transformations. You did that and made it go down there, and then you did your rotation. But it just wants you, having done this, to just say, how does this A go to C directly? That's what it says. So obviously, it's a rotation. You can see that because the orientation of this has changed. It was up like that, and it's on the side and everything. So you know it's a rotation. But you need to find the center of rotation. Where was it rotated about? All right. How do you do this? Okay, this is important. Get your tracing paper and just try, bigger tracing paper, and just try it out. It's normally in the region between the two. Okay, it's in that space somewhere. All right. All you need to do is literally draw this on your tracing paper and then just try out different points. But don't mark it. Just put your pencil there and do that rotation until it looks like that, the shape. You will find that it's been rotated from the point, I think I wrote -4, 1, right there. Okay, there. Okay, so you'd say rotation. And again, you'd see the number of angles that you did, and I think it's 90 degrees. It was clockwise from -4, 1. And there is your answer. Okay, question number 12. We have some graphs and we have to write down the letter that could have this equation. Now, I just done this the other week with one of my groups. I say to them, learn the graphs. Like, you should know the shapes of all the graphs. So very quickly, I'll do that quick lesson for you. These are the shapes that you must know, all right? Everybody knows y equals x. All right, this is y equals x. Any linear. It could be y equals x. It could be like something like this. But basically, the power of x is 1. All right, it could be like that. It could be like that. Anything. Okay. Just remember that x doesn't have a. Well, it does have a power. It's 1. Okay. It won't have like a 2 or a 3. The next one everyone should know is a quadratic like that. It will always have an x squared in it. Okay. So anything with an x squared like that has that quadratic. The next one is the reciprocal. Reciprocal is like that. So you have an x cubed. So it's got 2 bumps. Yeah, like that. Okay. Sometimes it might appear like this. Okay, like it's not got 2 bumps, but it has. Look, it's got 2 bumps here still. All right. Just remember that. This is your x cubed graph. So anything with an x cubed in it looks like that. Then another one is your reciprocal graph. So if you've got something like this, you know it's something over x. It could be 5 over x, anything over x. Okay. If you look out for those, you'll be good. Now, of course, you've got the negative versions of these. So if I put a negative, y equals minus x, and you just align that way. Okay. If I have a negative here, it will be upside down. If I have a negative for this one, it will just be like this way. If I have same thing. So I have a negative for this one, it will be like, sorry, not there. Let me just do it here. It'll be like that. Okay. So that's what the negative is. But those are the main things that you all need to know. Now, if you look at this, all right, you can see here, I'm not going to go there to the question yet, just here. All right, this is a x squared. All right, so it's a negative x squared. This one is something like 1 over x. Okay, this one is your cubic. It's got the 2 bumps, so it's something like with an x cubed in it. This one is something with an x in it, only it's a straight line. This one again is another cubed. It's similar to this one. All right, but what's the difference is it's going to have like other bits to it. It might be like 2x cubed plus 3x, something like that. Okay, that's it. But the main thing is the fact that it's got a cube in it. This one again is a cube, but it's a negative cubed. All right. This one here is a negative x. All right. This one here is a positive x squared. And this one here is a negative 1 over x. All right. It doesn't matter 1 over x, whatever. You're going to identify it differently anyway when you see what you've been given. So look right here. Write down the letter of the graph that could have this equation. Now this is going to have an x squared positive and a minus 4, which means it drops down by 4. Okay, so let's have a look. It's not going to be, we're looking for this anyway. All right, anything with that. So that's got that, but it's not negative x squared. So it's not going to be this one. And then this one. That's the only other one. Can you see? It's just elimination here. So you know it's h. All right, and it's got that drop by 4. Okay, so that is h. Next, minus x cubed. Which one is minus x? I think we've highlighted that. Here we go. There we go. We don't even need to do any more. Okay, there's no more minus x cubed at all. All right, that's f. And last one, minus 5 over x. That was there, right there. Look, no, the other one was a positive, wasn't it? Oh, we didn't have another one. Hey, there we go. There. Yeah, that was a positive. All right, so minus is that one because it's got a minus there. Okay, so that will be J. So H, F, J is our final answer. Draw a histogram for this information. Okay, first things first, guys. Histogram revision here. Frequency density is equal to frequency divided by the class width, and we can rearrange that to find, well, we don't need to for this question, do we? Yeah, we will do. But anyway, frequency is equal to frequency density times by class width. Okay, so to draw a histogram, we need to draw the frequency density, the FD. Okay, so we add that column here and just add some lines so everything's nicely structured. Okay, so we have, what do we need? We need the class width. So if we go to each one here, the class width. So what's the class width? The size, the gap between 0 and 10 is 10. The gap here, 0 and 30, it's 20. The next one is 5. Then we have 15. Then we have 10. That's our class width. And our frequency is right there. So look, frequency density for the first one is going to be the frequency, which is 20, divided by the class width, which is 10. So we're going to do 20 divided by 10. Without a calculator, we can do that. 2. The next one is 70 over 20. 7 over 20 is 3.5. All right, this one's a bit more challenging. 22 over 5. Okay, let's zoom in here. So how many times does 5 go into 22? 5, 10, 15, 20. So it goes in 4 times, and then we've got 2 over 5. So that would be written as 4 point. Remember, every 0, 1/5, 2/5, 3/5, 4/5. You've got to know these. 1/5 is 0.2. 2/5 is 0.4. So it's 4.4. 2/5. Okay. Right. Next one is 30 over 15. So that is simply just 2. 8 over 10 is, okay, 0.8. All right, so there we go. So now when we draw our axis for our frequency density, it's got to cover up to 4.4. All right, so we've got to decide how we break up the axis here, all right, which is really, really important. We need to go up to 4.4 at least. Remember, that's the highest number that we have in the frequency density. All right, so if I zoom in a bit more, if I say this is, can I do 1, 2, 3, 4? Yeah, that could work. So 1, 2, 3, 4. So that means each of these smaller squares is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 7, 8, 9, 10. Yeah, it works. Right, again, on the x-axis, we've got to break up from 0 to 60 here. Yeah. And it doesn't matter if it's what the intervals are, we need a nice breakup from 0 to 60. Okay, so let's look at that as well. So 0, if we say, what, can we do 10, 20, 30, 40, 50? Yeah, that works. 60, good. All right, now let's go for our first bar. All right, what do we have? We have from 0 to 10, so from there to there, it has to go to the frequency density of 2 right there. All right, that's going to be our first bar. Get your ruler and do this, please. All right, that's not great. I need to do better than that. If I'm gonna, there. All right, there you go. That's the first one done. We can just shade that in like that a little bit. The next one is 3.5 density and it's got to be between 10 and 30. So between 10 and 30, and what was it? 3.5, yeah? So 10 and 30 to 3.5, which is halfway between 4 and 3, yeah? Right there. Okay, so there, do your ruler, make sure you do that. There. All right, that's the next one. Then we have 4.4 between 30 and 35. So 4.4 between 30 and 35. 35 is there, and we have to go up to 4.4 right there, like that. Okay. So 4.4, 30 to 35. Okay. Not ideal. Sometimes it's off the line, so I'm just gonna, yeah. Okay, there we go. So that's that done. And then we have 30 to 50 and to 2. 30 to 50 up to 2. There we go. And lastly, 50 to 60, 0.8. 50 to 60, 0.8, which is right there. All right. Okay, there we go. That's done now. That's my histogram complete. I have been asked to now work out an estimate for the fraction of these people, of these 150 people. So I know that it's a total of 150 people. I could have got that from there anyway. Oh, it's there anyway. Who are in the shop for between 20 and 40 minutes. 20 and 40 minutes. Right, where's 20? Let me mark this in. 20 is right there. And 40 minutes is right there. Now watch this very carefully, guys. I need all of this, all of that, and all of that. Okay, that's what I need. Each of these, now you can do this in one of two ways. You could either find the gap here, so whatever this is and whatever this is, and then add that. One of two ways. That's what you have to do anyway. All right, but anyway, look, forget that what I just said. All right, just we need to find that green part. Okay, so we know the full amount of this, by the way. That's a complete bar. That's between 30 and 35 anyway. So we know between 30 and 35 was 22. The frequency of this is 22. So that's gap is that's given. The next one, this 20 to 30 is exactly half of what is 10 to 30. So what is 10 to 30? 10 to 30 was 70. Exactly half would mean half of 70, which is 35. So we know that. The only one is this one, okay? Now, I was going to actually use this. That's what I meant by the second way, and this is the first one of the ways. To find this, it's actually quite nice, actually, this question, because this is the full bar between 35 to 50, which we know was 30, and it's been divided into nice thirds. Can you see? All right, so we don't want the 2/3 part, we want the 1/3 part. So this is literally going to be 1/3 of, what's the frequency of this one? The total is 30. So 1/3 of 30 we know is 30 divided by 3, which is 10. So we didn't have to do much to find this. All right, so this is 35, all of this is 22, and all of this is 10. So if we add these together, that would give us between 20 and 40. All right, so 35 plus 22 plus 10. 35 plus 10. Let's do that first, yeah? 45. 45 plus 22, 65, 67. All right, so it's 67. Now it says the fraction of these 150, so it's 67 over 150. And that's your final answer. Okay, so question number 14 here. We have to expand and simplify this. Triple brackets. So what I suggest we do is we do this part first, but of course you could do those two first as well and then carry this on, but we're just going to do those two first. Okay, so 3x times 2x here, that gives us 6x squared. 3x times 3 is plus 9x, and then minus 1 times 2 is minus 2x, and minus 1 times 3 is minus 3. So that's one bracket, and then the x minus 5, we can continue writing it there. Then we need to collect the like terms right there. So 9x minus 2x is 7x. And we've got the 6x squared and minus 3 there. Now we have to multiply 6x times x, and that gives us 6x cubed. We're going to do 6x times minus 5, which is minus 30x squared. And then we're going to do 7 times x, which is plus 7x squared. And 7x times minus 5, minus 35x. And finally, we're going to do minus 3 times x and minus 3 times minus 5. So minus 3 times x is minus 3x, minus 3 times minus 5 is positive 15. And now we're going to collect all the like terms. So we've got this and this, which is minus 30 plus 7 is minus 23x. So we've got 6x cubed minus 23x squared. And then we're going to collect the like terms here. So minus 38x plus 15. And that's our final answer. All right, question number 15 here. OAB is a sector of a circle with a center 0 and radius 6 centimeters. The length of the arc of AB is 5 pi centimeters. Work out in terms of pi the area of the sector. So two things here. We know that the length of this arc is 5 pi. So write down the formula. So arc length is going to be theta over 360 times by 2 pi r, and then the area of your sector is going to be 360 theta over 360 times pi r squared. So using this part, we can say that this can be equal to 5 pi, and theta is something that we need to find here. Okay, so we need to find the angle theta using that, because we don't know it here yet. All right, so we are given the radius is 6 centimeters. We know the arc length is 5 pi. So the only thing that will be left to find is that theta right there. So we can have arc length, which is 5 pi, is equal to theta, which we're trying to find, over 360 times 2 times pi times 6. So if we work on that, we get theta over 360 times by 12 pi. That's doing the 2 times by the 6. And then we've got this to deal with. Now, we can write it like this. 5 pi is equal to 12 pi theta over 360. So all I've done is multiplied that over there. But one thing we can also do is cancel out the pi's. We can divide by pi. So we can do it here. Okay, so we're going to divide by pi here. So we have 5 is equal to 12 theta over 360. Now we need to do this calculation, 12 divided by 360. So we can simplify that. So let's do it up here. So 12 over 360 and simplify that. So what can we divide both 12 and 360 by? They both divide by 12. 12 divided by 12 is 1. And 360 divided by 12. Now, if you cover up the 0, do 36 divided by 12. That is 3. And then add that 0 back on. So 30. So 1 over 30 is that simplified. So therefore, this will become 5 is equal to 1 over 30 theta. Okay, you can keep the theta down there as well. Now, we need to get rid of the 30. So if we multiply up here, we get 5 times by 30 is equal to 1 theta. That's what theta would be. So 5 times 3 is 15. Add the 0, 150 degrees. So now the question says to work out in terms of pi the area of the sector. So now we're going to use this formula. So the area of the sector would be equal to theta, which we now know is 150 over 360 times by pi times r, which is 6 squared. So that will be, let's simplify this. So we can cancel out zeros here. So we've got 15 over 36. divide both numbers by 3. So 5 divided by 3 is 15 divided by 3 is 5. 36 divided by 3 is 12. So we've got times by pi times by 6 squared is 36. So if we just do the 5 and 30, oh, actually, we've got 36 and 12. So they're something that can be simplified. So 36 divided by 12 is 3, and 12 divided by 12 is 1. So we end up having now 5 times pi times 3. We'll just do the 5 times 3, which is 15. So it's 15 pi. So the answer is 15 pi centimeter squared. And that's our answer there. Oh, I forgot to add pi there. All right, question 16. There are only n orange sweets and 1 white sweet in a bag. Syra takes at random a sweet from the bag and eats the sweet. She then takes at random another sweet from the bag and eats this sweet. Show that the probability that Syra eats 2 orange sweets is n minus 1 over n plus 1. All right, let's focus on here first. It says that there are only n orange sweets and 1 white sweet in the bag. So the total number of sweets in the bag, is going to be n plus 1. Okay, that's a total. So what's the probability that she eats 2 orange sweets? So we want the probability of an orange and another orange. Okay, so the probability of 1 orange sweet is going to be the probability of an orange, which is n, over the total, okay, times the second orange sweet now. Now remember, we're going to have 1 orange sweet less. So it's going to be n minus 1 orange sweet less over n plus 1, which is a total, but also minus 1 from the total as well. Now if you simplify this, you get n over n plus 1 times by n over 1, and then this cancels. Okay, the 1 and the minus 1 cancels, so it gives you n. Then what do you have? You have this to deal with. Now earlier on I talked about when you're multiplying, you should look to cancel. You can cancel these out, so you can divide those, and then you're left with n minus 1 over n plus 1, which is what the final answer wants you to have and show. Number 17a, rationalize the denominator. So you multiply the top and the bottom by the surd on the bottom. So it's root 7. So 1 times root 7 is root 7. And root 7 times root 7 is root 49. But a quicker way is just to do 7. Okay, so because the square root of 49 is 7. So that's your final answer there, root 7 over 7. Next, simplify fully. Root 80 minus root 5. Root 80 needs to be broken up. So root 80, how do we break it up? Breaking down surds. So we need to divide by square numbers. What's the largest square number that goes into 80? Well, off the top of the head is you could use 4 if you wanted to, but 4 may not be the largest straight away. But if you can't, find the largest square number, that's fine. Just do 4 times whatever you can do, which is 4 times 20. And then that gives us 2 root 20. But root 20 is also too big, and we need to break that up further. So root 20 is root 4 times root 5. Root 4 is 2, so you get 2 times root 5. But this 2 comes along and multiplies with that 2 on the outside, giving you a final answer of 4. So 4 root 5. So 4 root 5 is root 80. So if we go down here, we write 4 root 5 minus, and then that can be as it is. Now they are like terms. They are the same surd terms that you're adding. So you just do 4 minus 1. There's a 1 there. So 4 minus 1 is 3. So the answer is 3 root 5. Okay, question number 18. Show that this recurring number added to that recurring number can be written in that form. All right, so let's take the first part, which is this, and make that into a fraction. So we can say let x equal 0.151515. 15 is the recurring part. Now, if we want to get the same after the decimal, and we want to get another number, which is the same, 2 numbers, which are the same after the decimal, and take them away. So if we take times that by 100, we get 15.1515 dot dot dot, and the original version, which was x, is 0.1515 dot dot dot. So can you see after the decimal place, they are exactly the same. All right, so they cancel. So you're just left with 15 minus 0 when you take them away. Okay, so 100x take away x is 99x, and 15 minus 0 is just 15. So you get x is equal to 15 over 99. You can simplify that as well. So that can be divided by 3. So you get 15 divided by 3, which is 5. 99 divided by 3, which is 33. Okay, leave that there. For the second part, this one, you do the same thing. So you can say let x equal 0.2272727. That's the recurring part, remember. Okay, the dots indicate that. Dot, dot, dot. Now, we want the same after the decimal point. So can you see the 2727? We're in another version that has a dot 2727. All right. So if we're going to have to do two versions of this number. The first version will take all of this, the first three numbers, so onto the other side. So you have 2727 after the decimal place. That's 1000x. So we have 1000x is equal to 227.2727 dot dot dot. And then we are going to take another version where we just take this one over, and then this will just come to the decimal point, so it's times by 10x, or it's 10x. So you get 2.2727 dot dot dot. Take those away, because you can now look, take them away, they cancel. So you have 1000 take away 10, which is 990x, and 227 take away 2, which is 225. So x is equal to 225 over 990. All right, so we've got this situation here where we add in them. Well, we know that this, we're going to use the 15 over 99 version, is going to be added to the 225 over 990 version. So the simplified form might not be useful here for us right now. So if we take this and times it by 10, we get the top to be 150, and 99 times by 10 is 990. So can you see the denominators are now the same? Remember, we don't have no calculators. All right, so we can just add the top now. So 150 added to that, so 225 plus 150 plus, or 225, add 100 is 325, add another 50 is 375. So 375 over 990. That's our answer. Does it ask for a simplest form? Okay, so it doesn't ask us for a simplest form. It says it just wants this number to be 66. All right, so the bottom number here needs to be 66 somehow. So how do we make this into 66? That's our mission now. All right, what we can do a quicker way, we can just do 66 divided by 990, and that would tell us what we are dividing by. Okay, and then we can divide 375 by the same thing as well. So let's do that one. So 66 into 990. So 66, we can't go into 9, so we have to do 99. So how many times does it go into 99? It goes in once. And 66 to 99 now is 333. So 330. So now we're going to have to write down some times table of 330. I'm just thinking, that's the best way to do it? Or can I just simplify? You know what? Let me try simplifying it. Rather than this way, let's just try simplifying it. So 375 over 990, because otherwise I have to do the 66 times table. And if I want to do up to 330, I might as well just, I'm almost there. Can you see? So let me just simplify this. So what can I divide by? I'm going to divide this by 3. So if I do 990 divided by 3, that is 330. And then the top, 375 divided by 3. 125. So that's 125. And now I need to do 125 divided by 330 divided by 5. I could divide by 5 now. Right, so what do we get here? 125 divided by 5 is 25. And 330 divided by 5. Now this one, you could count up in 5s if you want, or do the other way. So 330 divided by 10. So if we do 330 divided by 10, that is 33, and then times the answer by 2. So times by 2, so that would be 66. There you go. So the answer for M, the value of M is 25. Okay, so M is equal to 25. So m over 66. Okay, so question number 19 here. We have ABC and DAB are similar isosceles triangles, and they're in each other, so we should really draw them out separately first. So if we look at this small triangle here, we can call that A, B, and C, and the larger one is this triangle right there, the DAB triangle. So DAB, that would be right there. So D at the top, we have A, B on the bottom here. So the isosceles sides will be here, right there, because we told AB right there is equal to AC, and AD right there is equal to BD. So that's your isosceles parts. Then we are told that B to C is worth 4 parts and C to D is worth 21. So in total, we have 25 parts right there. Okay, that's just a ratio. Now, if we put it here, BC, and this is AB. Oh, so okay, that's referring to this part actually. So that all of that is A to B, which is 25. Okay, which also means this is going to be 25, by the way, because they are the same lengths. Right, so what do we have? Normally, we have a scale factor. Okay, so the bottom, if we correspond, we times by that scale factor. Okay, normally. So we can find the scale factor by doing AB divided by BC normally. Okay, so we can find that scale factor by doing AB divided by the BC length should tell us what our scale factor is. We have A to D and A to B. These are the corresponding sides on this particular example. Remember, this was just a ratio given to us, yeah? But so therefore, we have another version of this we can write is AD divided by AB is also equal to the scale factor, and those scale factors are going to be the same thing, so therefore we can equate them together, can't we? So we can say therefore AB divided by BC is equal to AD divided by AB. And then what can we do? Right, you know, B to C itself is given as 4. So we can have AB divided by 4 is equal to AD is also given to us as 25. So we can say 25 over AB. And then we can cross multiply. So we can take this up here. So that becomes AB squared. And we can take this there. So we have 4 times 25. So AB squared would be equal to 100. And the square root of that is just AB is 10. So A to B is 10. Okay, it's 10 whatever, like it's not centimeters, it's just 10. All right, so if we make another diagram of this, we can mark it in here that is 10. Obviously this is also 10. So if it's asked us for the ratio of A to B now compared to the ratio of A to D, A to B is 10 and A to D is 25. If we simplify that, can we divide by 5? So we can divide both by 5. That becomes 2 and 5. So the ratio is 2 to 5. There you go. Okay, next question. All right, question 20. 2 to the power of x is equal to that. 2 to the power of y is equal to that. Given that x plus y equals 8, work out the value of n. All right. So this can be rewritten. So 2 to the power of x is equal to 2 to the power of n over 2 to the power of a third. And this can also be rewritten. So you have 2 to the power of y is equal to 2 to the power of 5 over 2. So therefore, straight away you can see that y is going to be 5 over 2 from there. So therefore 5 over 2 is the value of y because the bases here are the same. Now this one, we need to do a rule. When you're dividing, you take away the powers. Well, they have the same base, yeah? So this becomes 2 to the power of x is equal to 2 to the power of n minus a third. So therefore, again, in the same way, we can say this is equal to that. So therefore, x is equal to n minus a third. All right. So now, if we add them together, given that when you add x and y together, you get equals to 8, we can work out the value of n from that. So x plus y is equal to 8. X is n minus a third plus y is 5 over 2 equals 8. So we're just dealing with this now. So if we add, because they're just adding them together, or you can just get rid of the fractions actually. Yeah, multiply by 3, the largest one. Okay, so if you multiply everything by 3, so multiply this by 3, this when you multiply by 3, the 3 cancels here, and this multiplied by 3 as well. Okay, so 3n minus 1 plus 5 times by 3 is 15 divided by 2. Okay, so we've still got a fraction here. Oh, and 8 times by 3, which is 24. So now we need to multiply by 2. Okay, so if we multiply by 2, what do we get? We get 6n minus 2 plus the 2 cancels here, so it's just 15 equals 48. Collect the like terms here. So if we collect the like terms, we get minus 2 plus 15 is plus 13 equals 48. Then we take away 13 from both sides. We get 6n is equal to 48, take away 13, 45, 35. And then n would be equal to 35 over 6. All right, question number 21, big 5 marker here. A solid cuboid has a volume of 300 centimeter cubed. The cuboid has a total surface area of 370 centimeters squared. The length of the cuboid is 20 centimeters. The width of the cuboid is greater than the height of the cuboid. Work out the height of the cuboid. All right, let's draw a cuboid. Okay, so we know that the volume of this is 300 centimeter cubed. The surface area, which is that side, that side, that side, the side underneath, the side right there, the side, where else are we missing? Oh yeah, the other side here. Yeah, all of them added together gives you 370. So surface area, actually, let's write it on the other side because I might need that space, is 370 centimeters squared. And the length of the cuboid is 20. So the length here is 20 centimeters. But the width is greater than the height. Now, this is interesting. If we say this is the height and this is the width, W is greater than H, right? We know that. Work out the height of the cuboid. All right, so let's start with volume first. Volume is width, length, height multiplied. Okay, so the volume we know is going to be 300 is equal to the width times the length times the height. And if we cancel by 0 and then divide by 2 here, so we get, or just do 300 divided by 20 is equal to WH. That gives us 30 over 2, which is 15, is equal to WH. So that's an expression or an equation that we have from using the volume. Surface area itself, so look, we have 2 of these, so that's going to be W times H for the one surface area. So W times H times by 2, because we've got 2 of them. And then this one is going to be 20 times H. And again, we've got another one at the other side. So 2 lots of 20H, which will simplify in a second. And the last one is the top right here. So this is width of 20, W times the 20 here. Okay, so we've got 2 lots of 20W. All right, and that is equal to the surface area, which is 370. Let's go tidy this up. So 2WH plus 40H plus 40W is equal to 370. All right, do we have any like terms to collect? Nope, not right now. Okay, right, so we have this situation now, but we are told this from earlier, that 15 is equal to WH. We've got WH right there, so we can replace that with a 15. So therefore, 2 times 15 plus 40H plus 40W is equal to 370. That would be 30 plus 40H plus 40W is equal to 370. And now what can I, okay, take the 30 to the other side. So we have 40h plus 40w is equal to 340. So we have this most simplified now. Now let's go back and look at some more stuff. So here, what we can also do is take this and make, like, because we've got h here and w here. All right, so if we make one of them the subject, so let's go with h, yeah? So we can say h is equal to 15 over w, all right? So then we can substitute that for here, okay? So we can have, so we can say sub h is equal to 15 over w into that. So we have 40 times by 15 over w plus 40w is equal to 340. Now we have everything in terms of w, you see? So 40 times by 15. So 40 times by 15. 4 times by 15 is 60. Add a 0. So you get 600 over w plus 40w is equal to 340. Times everything by w here. So we get 600 plus 40w squared is equal to 340w. We can take everything to one side and make it quadratics. So we get 40w squared minus 340w plus 600 equals 0. Divide everything by 10, at least for now. So we get 4w squared minus 34w plus 60 is equal to 0. Can we divide by 4? Divide by 2 for now. So we get 2w squared minus 17, 34, is it 30 is 15? Yeah, 17w plus 30. And then we have to now factorize that. So using whatever method, AC or otherwise, just get it into the two brackets. Okay, so if you don't know the AC method, make sure you go and watch that video. I do have it on my channel somewhere, but here I'm just going to go and do it like this. So on 15, 30 is 15. And no, it's too big. 6 and 5, perhaps. Yes, 6 and 5 would work. So what is that? 6 and 5. So 2 times that is 12. So they're both minuses, and then the 5, yeah, minuses. There we go. So W would be equal to 5 over 2. W would be equal to 6. All right, now remember what it said about the height as well. You don't forget the width and height thing there. W has to be greater than H, remember. So if you've got two values, we can only use one of them. All right. So do we need to find H? Yes, that's the whole point. Okay, so we can use this formula to do that. So H when, let's start with the easy one. W equals 6. H is equal to 15 over 6. H is equal to, what is that, divided by 3. 5 over 2, which is 2.5. Okay, centimeters? Yeah, 2.5 centimeters. And when W is equal to 5 over 2, or 2.5, we get H is equal to 15 over, I'm going to do 5 over 2 like that, by the way, because then I can take this number and multiply at the top, which is 30. So it becomes 30 over 5, because you just multiply that number at the top here, yeah? And 30 over 5 is 6 centimeters. So let's have a look at the two scenarios. Remember, W has to be greater than the height, okay? So W has to be greater than the height. So the first scenario is when W is equal to 6, height becomes 2.5. That matches that, okay? Because W is greater than the height. On the second scenario, W is equal to 2.5 and H is greater, it becomes 6. So this doesn't match it. So that's the scenario. So height is equal to 2.5 centimeters. There you go. All right, question number 22 now. So sketch the graph of y equals sine x between that. Here it's just testing you that you understand it's 1 and minus 1. So sine always starts on 0 here. Sine of 90 is 1. Sine of 180 goes back down to 0. 270 is minus 1. And 360 is that. So there you go. But you know what? This is a D. Oops. Sorry, I'm not looking properly. So there, there, and there. There you go. That's fine. That should do. Right. Solve the equation 2 sine x equals minus 1 for that range. Now, the 2, we need to get rid of that 2 first. Yeah, right there. Okay, and to do that, we divide by 2. So sine x is equal to minus 1 over 2. Then we need to, oh, it's a non-calculator. All right, so you need to know the things on the ratio, the trig ratios. So very quickly, what some students do on their fingers, I do it like this. So 0, 30, 45, 60, 90. And then divide by 2 here. So you have 0, 1, 2, 3, 4, 4, 3, 2, 1, 0. We are looking for the sign of something that gives a half. Don't worry about the negative for now. Yeah. All right. So what gives us a half? So root 1 over root 2. So you can see it's 30. Okay. So sine of 30 gives us a positive half. Okay. So if we look at the sine of 30 here, so sine of 30 is somewhere here, goes up and goes about halfway. Okay, so now we are looking for a gap here of 30. Okay, the gap here is 30 from there to there. It's symmetrical, isn't it? So therefore this, whatever that gap here is also, sorry, this way, the other way, here. Hold on, there. Okay, so you can also look at the gap here as well, which is 60. So you've added 60 here, all right? But here, more importantly, there, 30. 30 is there. So this also gives us a half, all right? But we're looking for a negative. Where do the negative half goes? It's on this part of the x-axis. So the negative half is right there, okay? That's one there and another one there. These two give the negative half. But the important thing was that you understand the gap here is 30. The gap here is also 30. So the gap here is going to be 30 and the gap here is going to be 30. So to find out what these angles right here are, just take away that 30 from there. Okay, so minus a half somewhere there. All right, so we know that this here is 30. So 180 plus 30. Yeah, which is 180 plus 30. That's 210 degrees. And then the other one was right there. And again, that is 30. So this one is going to be 360. Take away that 30, which is 330. Okay, so your two solutions for this are between 0 and 360. It's going to be 210 degrees and 330 degrees. This is actually an A-level standard of question, by the way. Question number 23. C is a circle with the center 0, 0. L is a straight line. Now, quick reminder, the equation of a circle is x squared plus y squared is equal to r squared. The center, when it's 0, 0, that's the case. Okay, so that's when the center is 0, 0. L is a straight line, y equals mx plus c style. The circle C and the line L intersect at the points P and Q. Okay, so they intersect twice. So it's not a tangent. The coordinates of P, okay, let's draw this because it all starts to make sense when you draw stuff. So there's your equation of a circle with a center 0, 0, radius which you don't know yet, and then this line, a line like that for now. Okay, this is the line L. But we know that there's 2 points of intersection right there and right there. Okay, and the points of P are 5, 10, and the X. Okay, so this is the point P, which is 5, 10. All right, so this is 5 down here and 10 right there. Okay, and then the other one, Q, the X coordinate of Q is minus 2. We are given the X coordinate of Q as minus 2. So we know minus 2, we don't know the Y. That's probably what we need to find at some point. Oh yeah, there you go. L is a positive gradient, so that is correctly drawn. And it crosses the y-axis at 0k. So C right here, that is k right there. Okay, is k. Right, so that's the intercept as well. So what we can write down for this is y is equal to positive gradient, we don't know what it is, plus k. That's what we know of the equation of L so far, the line L. We want to find the value of K. Right, so we know that K intersects at 5, 10. So we can use those points to sub it in. So we can sub 5, 10 in there. So we have 10 is equal to m, which we don't know. 5 is the x coordinate plus k. So that would leave us with two unknowns, which is not a problem. 5m plus k. That's one version. Because we know radius is simply anything from the center to any edge, we have a full coordinate there, and we know the coordinate here is 0, 0. So we can actually find the radius. Let's go ahead and do that. So radius is going to be the distance between the center to P. Okay, so the formula for finding the equation of radius is square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so it's going to be x, which is your 5, minus your 0, because remember the coordinate here is 0, so 5 minus 0, 0. Okay, so squared, plus the y coordinates now, so 10 minus the 0 squared. Just so you're aware, so 0, 0 is the center, coordinate of P was 5, 10. So we're literally finding the length, the distance between those two using this. Okay, so that would be 5 squared, which is 25, because 5 minus 0 is 5, plus 10 minus 0 is 10, squared is 100. So we have 125. If we break this, we can leave it like that. So that's the radius, okay? But in here, in the equation, it's r squared. So therefore, r squared would be just 125, okay? Okay, we can leave it like that. Right, so let's use the equation of the circle, by the way. So we know that the circle goes through Q, point Q. So we're going to sub point Q, which is minus 2y, into the equation of a circle, which is x squared plus y squared equals r squared, which is 125. That's the equation of a circle. So minus 2 will go in here, so minus 2 squared plus y squared, which we will find is equal to 125. Minus 2 squared is 4 plus y squared, 125. Y squared would be equal to 121. Therefore, y would be equal to plus or minus square root of 121, and that is plus or minus 11. So here we have two values of y. Now, one thing I want to bring down here is this diagram again. I just want you to look at this again. All right, and the information that it tells us about L being a positive gradient, but cut in the y-axis at the point 0k. I want to show you that we can have two versions of this happening. All right, here's the first version, right, which I did. This will imply that y is a positive 11, but we could also have that line coming down here. Okay, still a positive gradient for L, right, but we could have at minus 11 for Q. So Q could also be a line that comes like this, and it's Q right there as minus 2 still, but a negative 11. So there's two different versions that we can potentially have for Q. All right, but the important thing to remember is that the gradient has to be positive. In both examples, the gradient is positive. Okay, now what other information do we have? All right, so let's find the gradient. Okay, so we're going to find the gradient. We can have two versions of Q. Remember that. We've got a positive 11 version and a negative 11 version of Q. So if we start off by finding the gradient between the points, if it was positive y coordinate for Q. Okay, so let's see what happens. Gradient is y2 minus y1 divided by x2 minus x1. So this is one version, yeah? So we're going to do 10 minus 11 divided by 5 minus 2. Okay, so 10 minus 11 divided by 5 minus 2. 10 minus 11 is 1, 5, that is a seventh. Okay, and the second version is if we do the other gradient, so 10 minus 11. So 10 minus 11 over 5 minus 2. And this one gives us, oh, sorry, I meant to do 10 minus 11 is minus 1. Okay, so there you go. That's a negative gradient. That gives a negative gradient. Gives negative gradient, which we don't want. Our line was supposed to have a positive gradient, remember? Right there. L has a positive gradient. So this one gives a negative gradient. So it can't be between these 2 points here. Q has to be a positive. Hopefully we're going to verify this here. So 10 minus 11 is positive. So therefore 10 plus 11, which is 21. 5 plus 2 is 7. And that gives a gradient, which is 3. And that's the one we want because that is a positive gradient. Okay, so now that we've found our gradient, which is 3, we can go up here and now say the equation of a line is 3x plus k. Now remember earlier on, we were finding it like that. We can sub it in there if we want to, but this was subbing in 5, 10 as well. It doesn't make a difference because we know that the gradient is 3 now anyway. Okay, but we'll go back and sub it in there. Okay, so, or because we've done that already, we're going to think, oh, what's the point of doing that? You could sub it in there, right? You sub in m, you're 3 in there, you get 5 times 3 equals 10, and then k on the other side. Take the 10 to the other side, k is equal to minus 5, right? But I'm going to show you using this. So now we're going to sub our q value in there, which was minus 2 minus 11 now. Minus 11 is equal to 3 times minus 2 plus k. That's minus 11 is equal to minus 6 plus k. Add that 6 to the other side, you get minus 5. There you go. K is equal to minus 5. And that's the answer right there. So that's the last question. Hope you enjoyed this video. Please don't forget to give it a thumbs up. And if you haven't subscribed, what are you doing? It doesn't cost you anything. Make sure you subscribe and make sure you share it with your friends and other people who might benefit from this, okay? Bye for now. See you in the next one.